of the entire project. Okay, and also when this is in a construction project, you need to know how many of them and what are the panels that have been installed and what are not. Okay, and of course, because we are doing a very small project, so probably you will install all panels in one day, but that's okay. I just want you to consider a database that is able to define all this information in the database and then make relations between the required information, the required data. Okay, and the first requirement is that in the database, we can find out who are to be responsible for design and or for fabrication of each panel. Okay, I mean it doesn't mean that this person has to make the drawing. I mean, maybe this drawing is drawn by someone else, but this person is responsible for the completeness and the correctness of that information. Okay, understand? So you have, I mean, in the team, you have to like assign each person with his or her responsibility in design and fabrication. Okay, I mean, I want to do this just like it is a real construction project. Okay, I know. I mean, for this kind of a very small project, this is too much. Okay, usually we don't need to do things this way, but I want you to experience this management work that might happen in design and fabrication and also installation processes. Okay, so for the homework, every team please create the base, and the base has to be shared to every teammate and also shared to me, so I can access your base and then see what you have been doing. And you submit a file for slides that introduce the base of your team. I want you to report to the class how you design your base and how is it to be working on that. Okay, and right now I set up the date as the 5th of June, which is 2 weeks from now. Okay. Okay. Questions? And today, the first hour, I'm going to do some introduction to database for you, so you get a general idea what a database it can do, and especially relational database. Okay. Okay, and you already know Airtable. Okay, so I want you to use Airtable to define your own base. Okay, for these purposes. Okay. And also, after you have done this, then in the final project, it's also a part of your work. Okay, so it is complete, not only the physical construction, but also including this information construction. Okay, and you can imagine that this database is becoming a database for operation and maintenance after the whole structure is completed. Okay. Okay, so for today, this is a video. Okay, and you can watch it anytime. And I find this one, I think this is a very good material. Introduce database is from these two, Deborah and Charles, maybe gentleman or lady, or I don't know. Okay. Anyway, I find a very good material that so we can talk about database using this material. And these are the two Excel files provided by team, I think team B and team C, for measuring the mobile structure, mobile street, measuring the measurement. And they both use Excel to organize the data. And if we have time, then maybe after we have completed this introduction to database, then we can start to think about how to use the concept of database management, relational database management, for this kind of information. Okay, and if you are not familiar with Airtable, then this is a link to Airtable, and it tells you how to do for what you want to do. Okay, and this is the homework. Okay, so let's go to this slides for database management. Okay, if we go to the first page. Let me stop this. I have record screen scratch, and then I put this onto the model. Okay, Sam will come to our class at 2:30. Okay, so from 2:30, you are going to report your progress, and then we can discuss this theme. Okay, these slides are from where? Or from these two gentlemen. Okay, and it is part of a book. Okay, like a book. So it's chapter 14 for databases and the database management systems. Okay, so the first part is the objectives. Okay, first we need to understand what a database is, some terminologies, advantages, and disadvantages. Okay, and we need to know some basic concepts, characteristics of the data, also the structure of data, or you can call it data hierarchy, relationship between entities. Entities means like a chunk of data, and also the definition of data. Okay, and what does it mean by data integrity, and how important it is? Security, privacy. Privacy has something to do with security. It's relative, similar. And how they affect database design. Okay. I mean, this part is not so relevant to us. Okay, and then identify some basic database classification. For example, the most important type of database is relational database. Okay. This is the most common database model and discuss how they are used today. Okay, again, relational database. Understand how a relational database is designed, created, used, and maintained. Airtable is a kind of relational database. I mean, it is not pure relational database. It's kind of hybrid. So it also make use of some other database model. Okay, so it's kind of extension to relational database. Okay, and also included in this material describing some ways databases are used on the web. Okay, this is just an overview. Skip it. Okay, what is a database? First, what is data? What is the difference between data and information? Someone like to have your suggestion or your opinion? What is this different from data and information? When we say data, the way I explain might not be the same as other people, especially on the textbook. Okay, you just use my explanation as a reference. Okay, and because I think it is very helpful, at least to me, help me to understand many ideas, many concepts, to distinguish between data and information. Data is something that you can manage. You can store it, you can transfer it, and you can change it. So it has to be in some kind of physical form. Like if you have a piece of paper and then you write some words on it, it is data. Okay? Because you can write it, you can delete it, you can give it to someone else, you can leave it in the drawer and then come back to read it next year or tomorrow. Okay? So it is physical substances that you can use it to distinguish different status, different state. Okay? It is a means to make difference for something with other things. Okay, on the paper we can use a pencil, so we can put some black mark on it, so it becomes different from it was before. So with kind of media we can make differences on some physical substances. So using this function, we can record information that we want to remember. Okay, so this is data. But then information is not something that you can transfer. When I want to talk to you, I have some concept and I want you to understand it. I cannot send to you directly the information. So I have to convert this information into data. So now what I'm saying, while I'm talking, my voice becomes vibration of the air. So this is a physical substances. And we can record it using a recorder, and then we can play it maybe tomorrow or next week. And then the air is the media that can transfer this data. So it's a vibration on the air. So in order to communicate with you, I cannot send the information directly to you, but I can convert the information into data, which can be voices, my voices. Indeed, it's a vibration in the air, okay? So it's kind of physical substances, so I can store it, I can transfer it, and then your ear can sense it, and then your brain is going to interpret the data that I sent to you, and then get the information inside the data. Okay, so this is the difference between data and information. Okay, so usually we call data management system, but sometimes you also heard of the term information management system, right? And I would say it's because the part that you want to emphasize is different. For data management system, I think the focus or the major point is that you want to manage data. Okay. But for information management system, the point you want to emphasize or focus is how you present the data so that the person look at the data that you presented, they can very efficiently interpret the data and then retrieve the information which is hidden inside the data. Okay. And for information management system, I would say it requires a database management inside this information management system. So in the information management system, you have actually a database management system, and then you add on it some interface, very well designed interfaces, so that a person, when get the data from this database management system, they can retrieve the information very easily, very efficiently. Okay? But now we are talking about management of data. Okay? And second, database management system. We can use a management system to create, to maintain, and to access. So these are the three important things that we want to do, or the function of a database management system. And in order to provide this function, we need a database engine. Through this engine, the user of database management system can communicate with the engine so that we can access the data, create data, and we can also maintain the data. Okay, so the engine actually is a computer program that can store and retrieve data. And these are some tools, for example, like Microsoft Access, OpenOffice Base. This is a free software, so if you want to experience database management system, you can download this OpenOffice Base, or Horror Paradox, Oracle database, something like that. And there are more, much more. Okay, a database typically consists a set of tables, and a table is a collection of related records, and inside the record it consists of fields which describe the attribute for each entity. So it is regarding single category. Category means data type. So for every field of data, you need to specify what kind of data are to be stored in this field. For example, it can be an integer or a floating point, which is a number with decimal points, or a string, a text, or date, time, okay, and so on. Okay, name, telephone number, etc. And a record is a collection of related fields. For example, when you want to describe a person, you need a field for his or her name, his or her birth date, his or her occupation, addresses, telephone number, something like that. So each of this is a field. and then combine together all this set of fields describe an entity such as a person. It becomes a record, and they appear in the table as rows. Okay? And inside this row, each column describe field. So this is the basic structure, and then with column and rows we have tables. Okay, so I mean this is kind of convention. Of course you can reverse it, but basically everyone or most people organizing data into tables this way. Okay, and now when we have a set of tables, so a database is a collection of tables, and each table is a collection of records, and each record consists of a number of fields. So for example, let me enlarge this. So if we take a look at this table, this product table. So first field or first column, we have product number. So every number is like a product ID, the identification of every product. Okay, this database is meant to help us manage our inventory of some products. And then for each product, we have a product name. Okay, the first one is ski, boots, poles, bindings, or wax. Okay, maybe this is kind of inventory for kind of a sport shop in a ski resort. And then the skis is supplied by this company, Alice Ski Corporation, and the price is 90. And the boot supplied by this company, and this is the price. So for the inventory of this shop, we have a table to store all the product which is on sale for the shop. Okay? And then we need another table to record how much inventory we have for each of the products. So for product number A202, so here we can find A202 is ski. Okay, and in this table it says that for this product, the current stock is 15. Okay, has it been placed an order to the supplier? Okay, so maybe 15. We need more, so we have issue an order to the supplier, which is this company, so that someday they will send more ski to the shop. Okay, so this table is simply a table recording all the inventory of all products. So we know how many are still there in the storage. Okay, and then this table records the order. So this is the order number, and then the order is for A202, which is ski, and then the shipment date. So on January the 8th, we are expecting the supplier will deliver 30 ski to our storage. Okay. So and the second one, okay, so this database consists of 3 tables, and each table describes a type of entity. So this table describes product. This table describes the status of the storage or the inventory, and this table describes the order we have placed, we have issued to suppliers. Okay. Any questions? You get the idea, right? Okay. I think you all understand this, but maybe we need to go through it in order to make everything very, very clear. Okay. So you also know the link, right? Now we have like someone sitting in front of the monitor, and then he placed an order, so he filled up some form. And what he or she filled up in each of this field eventually goes into the database. Okay, so for example, if we want to place an order for like a A351, okay, which is not there, so it is not yet on order here. Is a no here? See here? No. Okay, there is no order to A351. So we have to turn on a dialog box for placing orders. And maybe somewhere here you have to type in the product number. Okay? Or maybe the program will show you a list of all the products, and then you simply select the product that you want to play. If you want to issue the order, so you find out that, oh, the product number is A351, so you fill up A351 somewhere here. Okay, and also you need to specify the quantity, okay, and also the expected shipment date. So you have to tell the supplier the product should not be delivered later than this. Okay. And after you fill up the form, and then the program will automatically check the data and then put this data into the database management system. For example, it will create a new record in this table, okay, and then we'll change the value of this field from no to yes. Okay. And also when the product has been delivered, then someone has to fill out a form. Okay, if he is the person who is responsible for this, he actually received the delivery, then he has to goes on to this database and then update the value here. Okay, so for example, we receive product number A211, like 10 pair of boots, then you have to change the number here from 90 to 100. Okay, so that the database can be correctly maintained throughout the business process. So we are going to do this for design and fabrication, and eventually also for the construction. Okay, now we are going to more detail about the structure of this database. This is very important concept. It is called primary key. For every table, we need primary key. Primary key means field or fields. It can be more than one field. And with this one or more field will uniquely identify the record in a table. What does it mean? Boris, you know what this means? Can you give an example? What can be a primary key? For example, if we are using a database for the university, so the university need to have record for every student, right? And what can be the primary key for this table? Student ID. Okay, why? Because student ID uniquely identifies the record. Can we use name? Can we use a name?
Not really, because
Not really?
someone will maybe have the same name.
Okay, great. Okay. In some cases, we need more than one field. Okay, but let's not discuss that situation. Okay. Yeah, something like the name of the town. Like, what I say? Like the town that I'm living is called Yonghe. Okay, and I'm sure in this New Taipei City there is only one district called Yonghe, but there are other Yonghes in other places. Okay, so in that case we need both the name of the, how do you call it, the city, and also the name of the district, or the name of the road. Okay, in different cities they can have same name for roads, but we are sure that in the same city, in one city, there are not supposed to be two roads use the same name. Okay, so this is the concept. And why primary key is so important? Because this is the key for you to refer to another table, or you want to link two tables together. You use the primary key of these two tables. Okay, here we use it to relate that table to other tables. Okay, what is a database? Involve many things. First, we need to have database designer, person who designed the database. So in this homework, you are the database designer. And also you are the database creator, because then you have to create the database of Airtable. And you don't have to program it because Airtable has been implemented, so you don't need to write program for the database management system. Okay, and also database need administrator. So there is a person who is authorized to create tables, to assign, to specify or to invite users, to set up the authority of each user. Okay, and of course we have users, and the users are responsible for enter data, for update data, or to retrieve information from a database so that their work can be correct and efficient. Okay, what is a database? The evolution of database. From 40s, people manage data in flat files. What does it mean? Right now, how we manage our design data? In files, right? You make a drawing, you make a model, you store it as a Rhino file. Okay, and another person make AutoCAD drawings, which is the shop drawing, and we put all these drawings together, maybe in a web drive, a remote drive, and everybody can get files. Always sending mails. Okay, I'm the designer, and then I email my drawing to the contractor, to the client. So this is called management by files. And this is very, not the best way of doing it, very inefficient. Okay, and it has been like that since 1940s. And more advancedly, we can organize these files into trees. So for example, we have hierarchy, folder hierarchy. Okay. Or maybe inside each of these files, there are some tree structure. Like for layers, we have tree structure. We have top level layer, And then for each top layer, left layer, you have sub-layers, and for sub-layer, you can have sub-sub-layers. So this is like a tree structure. But then the structure of the tree is fixed. Okay, so through the 90s, we are using tree structure to organize data, and relational database using tables and relations were developed since 1970s. So this technology has been there for 50 years, okay? And it is still very, very important, very, very heavily used today. So this technology is kind of a very long life skill or long life technology that is very fair, and I think it will be continuously in use for the next 50 years. So if you get to know this, then it's going to help you for the rest of your life. Okay? Usually in the information age, many skill or technology are very short lives, okay, but not database or relational database. Okay? And since the 80s, we start to think about object-oriented relational database. It is still relational database, but it is extended with object structure. So you can view it as kind of an extension to the relational database. And then since the 90s, people talk about multi-dimensional database. Because how many dimensions a table is? We have column and row, right? So it's 2 dimensions. How about we have layers? Then it becomes 3 dimensions. Okay? And what we can do with this 3-dimensional database. Okay, so instead of tables, here you see talk about data cubes. Tables are 2-dimensional, and cubes are 3-dimensional. Okay, but they are still extensions to relational database. So since it was invented, developed 1970s until now it's 2020, and it is still very heavily demanded. Okay? I would say the combination of database management technology and internet technology shape our work in this age. Maybe you are not aware of it, but whatever you do on the internet, behind all the works, there are databases. Advantage? Basically, there are advantages. The only disadvantage is, well, increased vulnerability. Because we rely on database so much. So if the database is broken, then it's going to be very bad. For example, if the database of the supplier is broken, then you go to shops, you cannot buy things. Okay? There used to be a joke. Someone stay in the hotel. It's like a 5-star, very luxury hotel. And then in the morning, he go to the restaurant and he want to eat breakfast. But then the waiter told him that, sorry, we cannot offer breakfast today because the computer system is broken. Okay, it is true. It can be like that. Okay, when the database management system is broken, then you cannot do anything. Okay, because you don't have the right information for the things that you want to do. inside industry bus, before database management, how we record our information in data. For example, we use file management system. So for example, the same thing for the inventory. Maybe we have a file, probably an Excel file. Okay, like what you do when you measure the mobile street structure. So you create a spreadsheet using Excel. So for example, this is an Excel file for product table. So here you have product number, you have product name, you have supplier, and you have price. But then for the inventory, you need to create another Excel file, right? And what you need to put in this Excel file? You need product number, product name, you need supplier, because when you don't have enough stock, then you need to issue some order. Okay, so you need to know who is the supplier, and you need to know the price. Okay, you need to know the current stock and if it is placed on order. And you also need a table, an Excel file for all the orders. Okay, and what's the problem in this way of manage data? Why this is not good? You see many things duplicated. Here, the supplier, LSD Corporation, LSD Corporation, LSD Corporation. The same information appear 3 times. More than 3 times. Here again, Alice Skill Corporation. Okay. How about if sometimes someone have a typo, have a wrong spell or wrong letters on it. Okay. And the price 90. And how about someone make a mistake and then he mistype it, it become 80. So which one is correct? So there are a lot of problems if you follow this kind of file management system. Okay, data concept and characteristics. Before field record table, okay, this is kind of same thing, but it is focused more on the concept behind this data. Okay, so basically it tells you that we have hierarchy from the smallest one, fields, and then record, and then table, and then finally database. Okay, and these are the concept behind the design of the database. First, we have to think about what types of entities we want to manage in the whole process. So each type of entity will become a table, or in some cases become some tables, which combined together or linked together will describe the required information for this type of entity. And for attribute or for a field of this entity, we have to think about what is the characteristics that we want to describe about this entity. And typically they become fields in the entities database table. And also relationship between these fields or these entities, association between 2 or more entities. For example, a student and the subject he or she measured. Okay? So subject is an entity, and there will be a table describing subject. And student is also a type of entities, and there's a table describing students. And then we have another table to link student with the subject he or she is taking. Data concepts and characteristics. One student may take more than one subject. Okay? And in another direction, one subject can be taken by many students. So this is a kind of many-to-many relations. Okay, sometimes, which is not very often seen, it's not a common type, is one-to-one relationships. Like husband and wife. Okay? Or what else? So it's not very common. Yeah, not very common. And in many cases, it's one-to-many. Like people to people, you can have only one mother, but a mother can have many children. Okay. So this is one-to-many. Okay, so usually we classify relations between entities into these three classes. And there are specific ways to define this kind of relations using tables. Okay? We are not going to talk about details here, okay, but you just need to know these concepts. Data concept and characteristics. Okay, how we define data. When you use Airtable, you add a field to a table, right? And you need to specify what data type this field is supposed to be filled in. For example, it can be a piece of text or strings. For example, the name of a person. Or it can be a number. Okay. For example, like the stock of a product. Okay. So usually we have a few things that we want to specify when you create a field. First, you must give a field a name. Either you call it ID or name or birthday or whatever, you need to specify a name. And then you have to specify the data type, such as text, number, currency, if it is money, regarding money, and it's currency, or a date and time. And it's better that you have kind of description to explain what this field is meant. Okay, it is optional, but it is better that you always have a good habit to keep a good description. And also some other properties. For example, the size of it. I mean, if it is a piece of text, then how many characters you can have in this field. Sometimes it has to be restricted. Okay, for example, like 255 characters. You can have no more character than that. Or sometimes just 16 or whatever, depending on what you need. And you can specify in many applications for database management system, you can set up a limit for the field size. Format of the field. For example, if it is a number, then how many digits you want to have for this number? What's the precision of the number is required? Or the allowable range. Okay? When it is regarding the stock of a product, you need to have zero or positive number. Okay? Maybe you don't have negative numbers. Or maybe in some database, you want to manage negative stock. Okay, then you allow to have negative numbers. Okay, or when someone is maintaining or filling up data or create a record, then there are some fields which are required, which means the interface will not let you go or get away unless you fill up this required field. Okay? Otherwise, your work will be abandoned. Okay, and if you finish all the specification, and then this become, the definition of all the field, the data definition becomes the table structure. So you have to define all this specification to the field. Then you can call that the table structure has been defined. Data concept and characteristics. Okay, this is like a typical interface for someone to create a database. Okay, I think you can see this when you are using Airtable. Okay, I'm not going into this. Okay, like when you create a table, you have to indicate what is the primary key. And for each field, you have to specify what are the data types of it. And if you want to set limitations on the field size, okay, or whatever. And each database management system may provide similar interface for you to set up all these kind of things. Okay, let me skip this part. It simply says that in the data management system, there is something called data dictionary, which is specification for everything. Okay, data integrity, security, and privacy. Integrity means if your data has any conflict, are they consistent? Okay, and this has something to do with the maintenance. And usually you need to have some computer program to help you to check and maintain the integrity of your database. Okay, and the security privacy, let's skip this part. Okay, maybe one thing we need to think about. Usually, a database is accessible for more than one people, which means at the same time, there might be more than one person accessing or even editing the database. Okay? And a multi-user database management system has to prevent from more than one person editing the same data. Okay? So when someone is like entering the data for one record, then the record is locked to other people. Maybe other people can view or can see the data inside, but he or she cannot change anything on it until the other person who has already checked out the record, unless he or she finished the editing and then confirm that this work has been done. Okay. Then the system will let other people, if he or she has the authority to edit that record, then he can check out that record and start to work on it. Okay, so this is kind of a mechanism or kind of ways to maintain the integrity of the database. So see, prevent two individuals from changing the same data at the same time. This is also very important for our design and application database. Data security, okay, to prevent destruction and misuse. Okay. Let's skip this part. Okay, so it's important to set up the authorized level of every person. Like we also have this in Moodle. Okay, so you see Moodle, behind Moodle there is a database to manage everything. Okay, let's skip this part, data organization. The way you design your tables has much to do with efficiency. Data organization, yeah, this is regarding how you design your database. It is called normalization of database. Okay, so if you get into it, then you know that there are multiple levels for normalization, and depending on which level you need to design your database based on this normalization. And if you are doing it very good, then the database, the structure of the database is compact. Okay. Otherwise, it's not so good. Okay. This is called hashing. This is a technique to make a very huge database more efficient. For example, for a table, maybe you have hundreds of millions of records. And how can you find a specific record that you want in a very short time from such a very big table? Okay, so hash is a technique in computer science. Basically, if you want to find a specific level, record which has a number as its ID, as its identification, then you can use a prime number to divide it. And then when you divide it, for example, in this case that it is 23, then you get a remainder. Okay? And you know that this record is kept at this place. So this remainder becomes the address where you can find the data. Okay. So when you use the prime number 23, it's just like that. You have 23 boxes, and in each box you keep the records for your data. Okay, and then now someone says that I want to find the customer ID 102, and then you don't know which box is to be you can find this record, so you divide 102 with a prime number 23, then you get the remainder 10. So you go to the 10th box, and you know that the record is inside that box. So it becomes very efficient, because in that box maybe there are not millions, but maybe only hundreds of records. So you just need to go through these hundreds of records, and you will find this customer 102. Okay, so this is called hashing. Okay, if you get into the technology for blockchain, then you know hashing is a very important technology for the blockchain implementation. How it works? Boxes. Skip this one. This is called column database. It's the opposite. See, every record is like a column, and every row is a field. Okay, you want to check. Okay, let me try. A column in a database in which customers' names are stored will be referred as a field or a record or a table. Which one? Alright? Sorry, I don't remember anymore. What is your answer? A, B, or C? A, okay, correct. Okay, good. True or false? Data validation procedures are used to ensure the data entered into a database matches the specified type, format, and allowable value. True or false? I think I've skipped this part, but this is true. Okay. You want to validate if the entry of data is correct. Okay, the blah 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 contains metadata about the database table in a, okay, this is the data library. Okay, I also skip this part. So you know what is metadata? What does it mean by meta? Have you heard the term meta design or meta knowledge? Okay, when you say meta design, it means the design of design. How you design a good way or a good environment to do design. Or metadata is data about data. For example, data type. It is a metadata because it specifies something regarding data. Okay, but by itself, it is also a piece of data. Okay, and knowledge means knowledge of knowledge. You see, this librarian, people working in the library, they are expert in meta knowledge because they know how to organize the knowledge. Okay, actually the books. Okay, so they have very efficient classification on books. They know where to find what kind of book regarding chemistry, regarding engineering, regarding design. Okay, they have very good knowledge regarding knowledges. So that is meta knowledge. So I mean, whenever you see this prefix meta, then you just need to repeat whatever behind that prefix and then insert of in between. Okay? Get it? Yeah, data dictionary. Yeah, I was right. Database classifications. Okay? There are many different kinds of classification. First, we can distinguish single user or multi-users. Okay, databases are particularly useful when used by multi-users. Then it can be used for collaboration. Many people who want to work on the same project at the same time. So it has to be a multi-user database system. Okay, so first, single user database system. For example, you want to manage your own data, like your phone book. Okay, then maybe it's your private single user database. Okay, or you have too many boyfriends and you want to use a database to manage them, and then it's single user. Or multi-user database system. Like Airtable, we can create a base and then we share with many people. Then it becomes multi-user database system. So this is one way to classify databases. Or we want to classify database system based on the structure. First, very important concept is about client server. Okay. We may have a computer which runs the program for database management system, and then its hard disk will store all the data, and then people who want to access this database system, they use other computers which might be far away from the server, but then connect through internet Okay, so the computer which is used by the user is called the client. Okay, and then the server, which is a computer running all day long and maintain the database, and also the database engine is running on this computer, it is called the server because it provides services to clients. The user, they want to access data from the database, or they want to edit or input data to the database, and then the server provides the services for them, for the client. Okay, so this is very important concept when you discuss with someone else regarding your database system. Probably you hear this term, server and client, and you need to know what are they. Okay, here's both clients. Usually we call it front end. The database system has a front end, and this front end is the place where the client get into touch with the database system. It is called front end. Okay, and there's at least one database server. It might happen that there are many database servers. It can be called distributed database system. And then the database administrator, he has to manage the entire database, and then he has to manage the database through backend. Okay. So usually this is called client-server database system. I think in most cases it's like that. Okay, but then for client-server system, it can be multi-tiers. For example, between client and server, there is a part called middleware. So the client will not access directly to the server, but it will access the server indirectly through the middleware, which means there is another program probably running on another machine. Okay, and then the client contact to this machine through some interface designed for the client, and then the client will send his or her request or the data he wants to upload or download, send request through the middleware, and then the middleware convert the command from the client to a language which is readable and executable by the server. So the client need not to know the language or the communication, the way to communicate with the server. Okay? Instead, the client just need to know how to communicate with the middleware, which might be of higher level. Higher level means people can understand it better. And low level is usually for the machine. Okay, so the middleware is simply to provide a higher level communication pattern to the client, so that client will be learn how to use it very fast, and then it's not easy to make mistakes. Okay, so this is for until models, and there can be more than one middleware, especially when the system is meant to be used for many different kinds of client. So different types of client, they may need a different kind of middleware to provide a more friendly interface to them. Okay? So for example, for our construction industry, maybe we need to provide a specific middleware for client, because they are not expert, they are not professional. Maybe they don't understand engineering drawing. So if he or she access the database and retrieve a drawing, maybe we need a middleware to provide better graphical representation or better graphical user interfaces to the client. Or when the client has some specific maybe he's blind, so we have to convert everything into voices. Okay, then he or she need a specific kind of middleware to indirectly connect to the server. Okay, and another way, there are different ways to classify databases. Another way to classify databases is in terms of centralized versus distributed database system. Okay, this has more to do with how you want to design your database. So it is more secure, it is more efficient, or it is cheaper. Okay, let's skip this part. Okay, centralized database, usually you have only one server. Or distributed database, you have more servers. Okay, and there is another structure called peer-to-peer, which means every user maintains his own database and they share this database with everyone else. Okay, one example is blockchain. Okay, it is a pair-to-pair system instead of a centralized database. Boring. So it's same? No? Okay, not yet. Okay. Victor? So are you ready? So maybe you can be the first presenter. Okay? So we have group A, B, and C. Okay?
Makan siang aja gimana? Banyak siang enggak apa-apa. Merasa berdosa.
Minggu tuh katanya mereka mau ngajak makan es tuh nggak sih? Nggak tahu jadi apa enggak. Kemarin nggak sih? Oh iya. Itu kalau
前2周都在弄机械手，对那个预警在的那个，没有看到。今天为什么讲这个跟大家分享？OK， 我看看有没有办法把，哎，你是学生啊，所以我就把你变成那个。我懂啊，不行啊。干嘛这样子？
所以会没办法在水学期间去读其他的资料。
啊，这样看到了。
把图书馆资料。
因为我所有的资料都全部都在你手上。
就是说，苹果这个书下载就可以的。
OK， 他可以把它 pack 起来。
学校的这个组里面，每一部分就是你学觉得你要这个资料，有一个那个查询器。
哦。
这可能是麻痹的。
他为什么要这样？
同一天的这样。所以我必须用。
不是私人的企业。
所以我就必须用任何人的那个麻痹的方式，假如我查过。对，就是会，其实很多时候休学更多的准备论文做资料，但是你要做这种东西，有些 reference 要排序啊，跟多少。
不过很多论文是你直接 Google 可以找得到，那有时候会找到拿到 option， 但是拿不到全文。
对，而且它会给你一个标准，大概到 F
我有一个诀窍，你在查询的时候，比如说你要查machine learning，你后面再加一个 PD， 然后他就会帮你找。有时候这篇文章你按照正统的话找不到，但是他会帮你找到 PD 的答案，因为有时候就会有些人就把它放在上，然后他的那个搜寻引擎，那搜寻引擎，他那个电脑是24小时不停止在那跑，他就有事没事就到处去转找，然后找到什么东西他就放一个 index 起来，所以当有使用者正好要搜寻这个东西的时候，事实上他早就搜寻过了，只是再去把它抓下来。那有的甚至他把它 copy， 把人家的网页 copy 到
自己的特定
他的那个 data center。
对，很多。
所以有一些网页，人家主人自己都 delete 掉了，结果 Google 的 database。
还有一些特定的网页，其他的那个 center 是要收费的。得到那个 publisher 的许可，他怎么可以引用他们缴费？我就说不太，等于是他收你的那个 exploring 的费用，让你给他。
没有，需要缴费的那个通常是跟 publisher 有关。
都是。
他应该是取得他的授权，然后变成他的经销商还是什么
Elsevier 应该是有授权。
他们应该是有这种好，然后有的是地下的， 我知道，尤其是大陆，它有些网站，它就是它很会去收集这些东西，然后它卖给你。那这个它搞不好是没有被授权。
前几天那个大陆的几个论坛跟期刊的发现单位被取消了，然后几十篇的那个论文的那个取消刊登。
对。
大陆自己办的，然后什么公司或者什么集团的研究中心跟什么学校合作的研究论文，有些说是造假，或者抄袭的，删掉的几段几十篇。所以很多学校会对于那些论坛或期刊或是对大陆主办单位觉得说，难化了。我怎么看了一下，目前在期刊里面都是用关键字，我学生领的领域跟我们在做的这个 bespoke beam 的这个观念，有关于 bespoke beam 的这种 concept 的发掘期刊，
像我刚刚是跟朋友介绍那个 database 那个，事实上，那个不是我教的，那个网络他一开始有这个过去大家 manage 这些 data 的方法，主要就是 file。那 Firebase 就是很没有效率，然后你东西的重复一大堆，然后你看我们建筑到现在多半都还是 Firebase。我一张图就是一个范，
没办法 reference 去做写个行政的话。
好，即使现在谈并，大家也知道，按指示把你的 file 可能从都给这个，那你还是一样 ready 一个档一个档，那所有的 information 都在这个档，你要么你打开来看，可是我明明只要这些 information 里面其中一个部分，我却不能够把它抽出来。而且这个 information 被 lock 在这个档案里面，那这个 information 跟另外一个档案的 information 有关系，那怎么办？这个关系我只能靠人来建立啊，因为我就是打开这个档案，去阅读它，我早知道，然后再把这个档案阅读它，然后再往脑袋里面把它 relate。Okay, please you can start. So this is team A. Okay. So you are using the broadcasting system. You need to plug in. 哦，没有头啊，我有头。哦，妹妹，你是什么样的头？Mini HDMI。You use King Kong for this one. The plugin? No. Is it good, King Kong? Have you been using? Do you have it? King Kong 是做这种 curve forming 的一个程式，可以 plug in 在 Grasshopper。
它有一点过程，plastic polymer，
就是 PP。
so basically this is what we have. It's the design. Then there was that seam problem, so we took those seams and then we dealt with them separately. For those seams, we rebuilt the surface and then we dealt with them differently. So these are the final designs that we're going to make, and obviously all of these pieces will become like that. And these pieces are made, although are made flat, so it's just laser cut flat, and then we just bend them upwards. But then when we bend them, it becomes slightly shorter because the material flexes. So we have to calculate how much distance from point to point prior to a folding, and then once we fold it, it has to become the right length. So we did some, I guess, statistics, I guess, if you want to call it that. Basically, we did some small scale prototype and then did some interpolation on the data, which gave us which gave us like a curve that we could calculate. So we could choose how wide this middle section is and then what angle we want it, and then it will tell us how much we need to add to the overall length so that when it flexes to the right angle, it's the right length.
So you mean you have to adjust the way you have this fold, and then so to make it
Just the way we have it.
precisely fit onto the grid structure.
So we
Or
are.
if you can enter the grid structure as input, and then the script, the program will tells you how it can be curved folded.
So here we have all the panels already have the angles, right? We already predefined, we already designed all the panels.
Okay.
You know, all the panels already have the angles. The problem is that once you fold something like this way, it becomes shorter
That's
than
right.
when it was in 2D. So when we have to calculate how much shorter it would become at that angle, and we also have to decide how wide we want this piece
Yes.
to be. So in theory, yes, we could just take all the data from this angles and then put them into this calculation, and then in theory, it should give us all of our pieces, all of our length.
Yeah.
We haven't actually tested it out yet, but
Okay.
it should work.
Okay. You need to find out an algorithm for doing, I would call this kind of top-down design.
Yeah.
So you know precisely, since you have measured the size of the grid, right? So you know precisely the joint,
Yeah.
the distance between the two joints it has to be,
Yeah.
okay? And then you have this input, and then the script will automatically generate the right kind of curve fold for you.
Mhm.
So after you fold it to the desirable angle, then the distance between the two joints will perfectly match
Yes.
the grid.
Yes.
Okay. And is it possible that, okay, right now you have every panel differently,
Yes.
different.
Yes.
Okay. Is it possible that, like maybe for some grids, you have identical shape, but with different fold? And then with this fold, you can adjust the distance of the two joints to fit specific grid,
What do you mean different fold?
different curve
Oh, curve. Okay.
for folding.
Yeah. So
Because
here-
then you can change the curvature so that after you fold it, the distance of the two joints vary.
Mhm.
Okay? So, I mean, it's a way to compromise between customized fabrication and mass fabrication. So you have same shape for every panel,
Yeah.
but then you change the fold. So that after it is folded, then it becomes adjusted. The distance between the two joints is adjusted so that it fits perfectly to the specific dimension of every brick. This is another, possibility. Okay, and it's just a simple suggestion. Maybe you can think about that.
Okay.
How can you control the radius of the pan area of this bird shape? We call
The center part?
yeah in the metal sheet or in the plane we call when you form it, this is wing to wing, we call this is plane.
Okay.
This is the bottom area, which is like a plane.
Yeah.
So when you fabricate it, actually you have it flat.
Yeah.
So the distance between this node to this node is flat. Same at the same plane with the other two curvature.
Yeah.
So, but when after you rotate it, you fold it up. That create the curvature
Yeah.
due to this three. There is an invisible line.
Right.
So you got three line, which is running toward from one node to the other node, but through different path. So when you fold it, this is the plane, still remain flat, but the wing is kicking up due to the radius. So that will also create the curvature of this bottom,
Right.
of this area. How could you, is there any methodology you can control your curvature of this plane? Because if you are not able to predict it, then you might end up, you have different curvature,
Yeah.
which you are expecting to be with the same radius, but actually you might not, if the size is various.
Yeah.
Even if you adapt the same radius, center line to a curvature, but if the size is different, you might have a different radius for this plane. It's a map. I assume if the distance is changed, unless either you remain the radius of the center line to the curved line, unless you remain the radius in the sequence. Otherwise, when you fabricate different size of a panel, you might get a different curvature at the end.
Yes.
So that will become, we are not able to predict the curvature from the pan area. So this bird will become like this. Some of it will kicking up high, some will be low, and then the wing angle will be various. Will be just like this. Will be various.
That's the point of the design, is that all of them are various.
Right, but we want to know whether it's in this degree or in that degree, isn't it? Because when we look at this in the distance, we want the wing to show the variance in this way.
Yeah.
So we still want something which we can predict, but I don't know how can I predict from your programming methodology. Actually, I'm trying to learn from you. So I have a question. If I want to see a bird which is flying with the action with the moving wing from this to this, which I'm not able to predict. I don't know whether you have the method to predict it or not. So far, I have a theory. That would be very interesting if you have a bird fly from here and then you have a shape like that. So it will travel with a different wing angle on a building or something. That's my question. This is very interesting. I was curious to know whether we have any method to predict the angle to be. And besides using polymer material, this is also could be done by metal with anything with the flexibility or
Yes.
elasticity material. They will do the same.
Yeah.
So you are thinking about using PP or using metal?
PP is easier to fold,
Uh-huh.
so we could also use metal, I guess. So metal.
You haven't decided yet.
Well, originally we just wanted to use PP because
Okay.
it's a lot easier.
So you use laser cutting machine to cut
Yeah,
this?
laser cut.
Okay. Okay. I was not so sure if laser cutting machine can cut PP, but they say yes.
They,
Okay.
Laser can cut anything, but it may burn through or
Okay.
only burn the surface.
Yeah.
They depend on the energy that has been
Yeah.
discharged onto the surface.
Okay, I think so. This is good. Maybe you try out King Kong. If it can
King Kong is
simulate.
so
Sorry?
outdated.
Sorry?
It's very outdated.
Very outdated?
It hasn't been updated for like 3 or 4 years.
Okay, find out. I think there are programs, there are plugins so that you can simulate curve folding. So theoretically, we can handle the question that you just asked.
Yeah,
So
I was
depending
wondering.
on the curvature of this fold and the folding angle. Okay, you see this is a kind of smooth transition between plane, this part, between a planary surface to a curved surface. Okay, when you fold it in onto some specific angle, the curvature becomes maximized. But then it is a continuous change depending on the folding angle from zero curvature to maximum curvature. And depending on how much you fold, you can control actually the curvature by deciding the folding angle. But with PP, I would say that you are not really that able to control the folding angle. Perhaps it is going to be decided on the distance between the two joints, right? When it is far away, then this becomes more planar. When it is closer, then you need more curvature, and then maybe it eventually, after you install it, it becomes somewhat like this. Okay, but maybe you can adjust the distance between these two more effectively using the curve here instead of this folding angle. And then with curve folding algorithms, I think more or less we can predict that. Okay, you have to describe this as rule surfaces, and then you use rule surfaces to translate. But perhaps you can even use kangaroo to do the simulation. You don't think so? You divide it into strips and also into strips, okay? And you define forces to change the angle, or forces to change the length of it, and then see how the entire panel will be reaching the equilibrium state.
Maybe I can change my way of asking the questions. So if I want to install this on the sphere surface, which is like an earth, I want to show the bird is flying from this area and to that area. So actually, this curved line and the central line, the distance of the central line to the curved line will decide the curvature.
Yeah.
But due to the elasticity of the material, we may not get the theoretical curvature that we want from the program. But still, we still want to predict a range. And this will be able to cover a small sphere to a very large sphere. So I feel this is very interesting. If we install it onto a curved surface as a decorative material, we will be able to see the birds flying from here and there and with the different size of it. So this reason why I asked the question whether we got any methodology which we can predict the curvature more precisely. I know it's not going to be perfect, it's only thinking logic whether we are able to predict the things, predict the result after we have a program, and before we fabricate it, we can know something that which is going to be look like. Because this is a very interesting product, interesting shape as I see. Because the fabrication ways, the fabrication methodology is simple: punch in 2 holes, cut off the rest of it, and rotary 2 lines. So the process is simple and easy.
Yeah.
And it's going to be an interesting surface.
Yes, like if we find the right simulation program, we could do it. But we have to find the program first.
Or maybe just plug in a program of a sphere distance that you want in front of your program. Because if you predict there is a sphere, a ball,
Yeah.
and then you do the alignment on the ball, then you get a different methodology you can read your segmentation from the size of your ball. So you assume it's a reasonable and ideal sphere, so you can do the prediction. That's what I thought, and what Professor Shi was referring to is when we have a topology which could be assumed as a principal surface, principal curvature, which is a mixture of different curvature, but able to be principal, then we are able to adopt the logic to define the size of this product, of this profile, and they can create various of size and really looks like a group of birds flying from this zone of the earth to the other zone of the earth. Looks very dynamic. That's what we were thinking. We are inspired by what you have been done here. Try to make it to think of what else can we do with your design.
Have you read the paper regarding curve clothing? I think maybe not by you or by Boris or someone who has found a paper study curve clothing. Remember that?
Yeah,
No?
remember, Boris Group.
Boris group, read the paper.
Mm.
Then you will know how to simulate.
Okay.
Yeah.
So from the grasshopper that you wrote here, you can have the distance from center line. The distance is this is by centimeter, right? And the angle, what is the definition of this angle?
This folding.
Okay.
How much it folds up.
Oh, so you can predict the angle of this folding up.
Yes, kind of.
Roughly.
And the distance is here to here.
No, so there's a center line, the middle of a center line, the midpoint of the center line to the midpoint on the curve.
Which one?
So there's an imaginary line, and then from this line horizontally to a curve, to an
Like
apex of the curve.
Like from the center to this, like the radius.
Okay. Yeah, you assume there's an invisible center line here, and you adjust the height.
So
of
actually,
the arc.
it's just the curvature of
Okay.
the curve
Yeah.
flow. Okay. Okay. Well, so any suggestions, you guys? No? Okay, group B. You are the only one, right? Your partner, they need to go to the jury, design jury. OK， 他们几个当那个设计助教都被叫去
哦。
帮忙。discrete 变成线。那当然，你如果分割的越密，它就会越接近曲线。我不晓得，我去看试试。你看，我再来。还有 Q3D， 我觉得 Q3D 有那个，你可以你的 support 可以 fix 在。QECD 可以 ，QECD 我觉得比它好。我今天早上大学部的学生，你可以上我那个另外一门课。好，我那个资料还。Yeah, you can start.
My group is presentation and actually we changed our shape from before the wind turbine. Then we decided to change our method, also the shape, because we think that the lower position is hard to respond to the wind. Also, the frame shape also you can't use the wind turbine effectively. So we try to find another concept, and this is our reference, the facade of Marina Bay Sands Hotel, Singapore. This is using the wind facade, so just simply respond to the wind. Then we decide to make shipping facade, so responding also to wind. So we make this kind of structure. Like this. Then we put from the four side, and from for one frame, one full frame, we add like four plates.
For each
For
each grid, you have
yeah,
four
yeah.
panels like this.
Four panels, and we decided we want to use maybe wire rope, and the material of the plate is aluminum, so it can hide off, but also when the wind blows, it can also
Okay.
move. the folding.
What kind of material?
Aluminum.
Aluminum.
Because
How thick?
from this paper, yeah, we want it should be the thinnest one.
The thinnest one.
Yeah, because also from
Maybe
the
you have to
paper
ask
says,
Sam.
yeah.
What kind of aluminum sheet you can
But
use?
also
As thin as possible, because they want their structure to react to meat.
But also if you have another situation, this also is.
You may go through it first. They will let us to learn your
Oh,
whole
okay.
concept. Then we can come back to discuss whether what kind of material or substrate that you might adopt.
Oh yeah. Okay. And from this paper, this paper is like paper, also aluminum, also foam, wood, but the thickness is only around 0.5 until 1.5 millimeter, not more than that. And this is the simulation of the geometry, and this is how we use it with the grasshopper, and this is the movement that we want to make. And also we tried build.
So you use the King Kong to simulate this?
Yeah.
Oh. Does it work?
Yeah. Yeah. This is the one that Alex made.
Kind of discrete simulation.
Currently, you have developed a program to assume a particular geometry that you are expecting to come out, and from your conclusion and perspective, are you able to what are the fabrication methodology you might adopt to achieve the topology that you are looking from your paper conclusion and perspective? There is a page of conclusion and perspective, or you may show this page, the previous one. Yeah, okay. There is a routering line, or we call it pad, machining pad, that you have designed, expecting to happen from whatever the mechanism that you want to use. Am I right from this page?
You mean the concept?
Yeah.
The shape, yeah.
Yeah, that is the line that you are expecting in order to achieve your shape, right?
Yeah, so just for.
Yeah, that's the treble curvature or treble line that you are analyzing
Yeah.
for complete to achieve your topology, right?
Yeah.
And what kind of tool you might use in order to achieve the treble track.
Oh. Maybe the robot arm, but we also still not sure.
Yeah, I'm also wondering,
Yeah.
because it looks like that will be difficult to.
You may have to do it manually.
Yeah,
It's too difficult to use robot.
because you are using a plain material, a flat material, and create into a 3D geometry. So even if you use the robot arm down in the basement, you need to hold the panel the piece of flat panel, and I predict you will not be able to achieve your geometry because the four sides of the flat panel has been fixed already.
I would say you need to design kind of device,
Yeah.
maybe by wood or whatever. So the device would be kind of adjustable based on every individual panel.
You have to create your own fabrication tool.
Right, yeah.
Oh,
Yeah, and then you kind of doing it manually with the help of the tool so that you can control the shape. Okay? This will be extremely difficult if you really want to use robot arm.
It will be almost impossible.
It can be a PhD thesis. If you want to do that, you can get a PhD on it.
Because from this
It's not a semester project.
from this result,
Okay.
we can see it's not going to be a four size fixed product. You would not be able to produce or fabricate into a topology like this from a flat sheet because it is already 3D. The result is 3D,
oh yeah.
and the original paper that you use is a plan.
Yeah.
So like the one you hold is 3D already. So the four sides of your paper is this is the material that you put on the robot table and you fix it four sides, right? But the result, this is what you want. So the four sides of the plan clap gone. If you hold it,
Yeah.
then you will not be able to twist, you will not be able to curve into like this. So you see how can the four sides clap be twisted into this shape? It's a curve, it's a curve, it's a curve. It's a dimple. So a flat clap, I clap it, and if you clap it, then you are not able to fabricate it into a 3D geometry. You follow? Are you following? You follow me?
Yeah, but the flag is after the paper should be.
When you do the fabrication, you need to put it on the table, right? So it's flat, right?
Yeah.
Then how can you push it up and still with the clap in
Oh.
the flat?
Yeah.
Because you hold it in this way.
Yeah.
So that's really what Professor Su said, that if you are able to design a tool and make this happen, it's going to become a PhD thesis. That is going to be something very, very difficult, I would say. You will need to have several robot arm to hold it and able to allow to release it, and with another set of tool to push it here. We call it press. So this will be another tool to press it down and become like this. The most simple way that I would use without any high tech, I would say I would use something like a scissor press. Clap it here and I press it deep. I press it deep. So the bottom die is two row, upper die one row, and I press it in, it will become like this. That's the most simple way and cheapest way. Use a scissor, one, put in the paper, then I crush it. Understand?
Yeah.
That will be the most easy way
How
to
about
press it.
they fix it like this, and then a tool, so
Yeah.
just like the scissors that you say, and then you
And also adjust it. And also adjust the angle. That's possible.
And
So
maybe you also need to have some way to narrow down this, like my thumb and my middle finger.
Oh, it's a press.
So you have three parts of the tool. One part pushing it down in the middle, and then the other two parts try to fold it.
So it will become a mechanism, like one mechanism in this way, and the other one could be in this way or in this way. If I want to make it simple, I would say in this way. So press it and press it. It's a two mechanism. One is a scissor, the other one is a clamp, and then bend it.
So you need to design a kind of tool, okay, and then you handle this tool manually. Okay, so it might work. Especially, I mean, the material I'm going to use is very thin. Okay.
But can we make the line here, because it should be a line here.
Yeah, you
can
can
be.
mark a line.
Yeah, I mean, you have to laser cut it, right?
Yeah.
And also you cut a shallow fold here. Yeah, so it is easier to fold it here. Yeah, can be.
And you might want to do something like your drawing. Cut off the edge first, make it become a curvature first, because the tension here is going to be stronger with this triangle shape. So make it become a circle, looks like a circle with a radius. Cut off the rest of it, and then you, with a scissor to hold it, then this will become easier. Just like what you show here. Cut off the outer surface, and then you use a scissor for this area, and they want to bend. That will be easier, rather than triangular material. That will be
Okay, but
interesting.
I would say you have to try some experiment. So and what kind of thickness you suggest? Did they use aluminum sheet?
I think either something between 0.3 or 0.5, they will do as thin as possible, so that you can use your manual tool to make it
0.3, maybe.
whatever you can get.
Check if you can find from a 0.3.
Or even steel is also okay. Any metal with electricity. And if you want to use the polypropylene, the Team A as a duct, is also possible, but you will need to have a thermal heater on the scissor.
Oh, yeah.
Because when you press it down, you need to preheat it, soften it, and then cure it so the form will be fixed. The most simple thing that we can do is to use an air dryer to heat up the substrate and heat up the scissor, and then clap it, and you can see the deformation that you want. That's the simple way that you can do. And it's also it will be also easier for you to adapt anything to combine a shape. That is a scissor with the balls. So you got a small round, like a ice bar. Like anything with a round shape with a note like this, which you can go through with the balls to paper, your paper is pre-cut according to your plan, maybe into this shape, and then you can into a shape like that. So this is the tool. So you need to one scissor, which is three pieces scissor, and the other one is a flap. Then you can hold it, hit the material, hit the tool, and twist it, and then pull it down, then it was formed.
Yeah.
So if you want to do the fabrication in your dormitory, it's also possible by doing this way. You just use the plastic material and use the hair dryer to heat it up and bend it. Just do it once first, whether you got the right way to do it, it might be possible to be done. But with the flat plan, it will be difficult. You will need to cut into a curved plate. Cut the triangle plate into a curved plate first. That would be my suggestion. And that would look very interesting as well. And you can see that the drawing that you show actually is like use a round bar. It's a bar to push down the area.
Yeah.
Not the blade, it's a round bar. It's a bed. It's a bed.
Yeah.
That would be my suggestion. And that does not conflict with your original idea to wire it up or anything.
Another suggestion, you make holes, okay? And then you have iron wire, goes from this side, get out of the hole, and then get in again, and then you go.
I think I have seen some students in this class have another methodology by many, which is to laser cut the hole, laser cut it. Laser cut it, and then cold bending. Then you can use the laser machine down in the basement and cold bending it. Everything will be easy. You will still need this tool, but maybe not so necessary. This will be your laser cutting hole. Short, distant by distant, and then cold bending. You will achieve the shape as well. So there will be we call cold bending. Laser cut it and then we cold bend it.
Many different ways to do it. Or maybe if you follow the suggestion that I did, maybe you can use PP instead of metal sheet. Right? You understand what I said?
Not
Use
really.
PP,
Yeah.
and then you punch hole, one hole, two hole. So iron wire from this side come out here, and then run back in again here, and then make a run all the way around, and then go here, and then here, and then go to this side again, and then because it is wire, iron wire, so you can make the shape
So just to hold.
to hold it, and then with this two hole, it can hold the whole shape. And this is a PP, so it's kind of elastic.
Yeah.
But then the iron wire will fix it, the shape that you want. And then with this wire, you can, the iron wire is a way to to make the form.
Mm.
Okay. Yeah, many options. So you have to try and think which way is the best. You never know it until you actually try. Okay, so now we have our C, group C. Yeah.
Do you have suggestion also for the joint?
The what?
The joint.
The joint?
Yeah.
What do you think?
People.
I think last week we have talked about this.
Yeah.
You have something to hold the cable on both sides of the hole.
Yeah.
Small thing you can clamp on it and then fix the position on both sides of your panel.
No. Last week, our suggestion is to make a hole
Yeah.
and then put a wire.
And then your cable
Yeah.
goes through all the way, but then it is sliding, right?
Yeah.
But then the hole, both sides, you need to have some small things to fix
Yeah.
on the wire or on the cable, so that this panel won't slide.
Oh.
Okay, and I think you can find something like that. Maybe a small device with a screw on it, so you can screw it and then hold it very tight.
Mm.
Or maybe you know this kind of plastic. How do you call that? A plastic bell, and then with a head and then you penetrate it, and there is a zigzag pattern, and then you can drag it and then hold it very tight.
Cable this?
I don't know how to call that.
The one to the.
Yeah.
Oh yeah.
Okay.
Yeah.
And also, if it won't fit very tight, then you glue it.
Mm.
As long as it is larger than the hole, then it will somehow fix the panel. Wow, so this 3D print? Yeah. Oh, this is the PC.
Okay, everyone. Now we are proceed and want to share our design process and discuss the detail about the panel. And in the beginning, we start with the case study curve folding from ETH. They use unreached sheets, and and use sheets to make every panel and metal screw to fit it. We have written this before, so we can see it to our process. And this is our plan to make the panel from surface to assemble. And we will start draw the shop drawing for fabrication next week. And final assemble. And in the surface stage, we take a measuring on size to compare the difference between model and the size and 3D model in Rhino. And all this dimension from model on site. But we find some panels have large deviation value, and maximum can be 20 centimeter. So we need to measure again to this panel. And this page show how to use grasshopper plugin King Kong to help us on our design process. And this, so we take a prototype from the King Kong and so make a curve folding panel to choose how the prototype of our design. And this the developer of the King Kong show how they make the curve folding by roller arm. The company is called Robaco, and they develop the curve folding about the metal sheet. And they use a CNC machine to cut the panel. And they may want to use a robot arm to curve the panel. So in those 200 stage, we do the belonging, site measuring, and parametric design study to join and list cut and upload to the Airtable. And this, we found the panel that have measurement have something different between the model on site and 3D model. And we also remeasuring the diagonal distance and use the Excel data to make actually the dimension the panel on site. And this how we control the surface parametric pattern use the grasshopper.
In the second part, we studied for the joint. We look some example from another building. So we made this three model kind of joint. The first one, the second one, and the third. But we after we make it and try it, the first one is just like this. We make connection from the corner of the panel and the screw with the joint, and we make from 3D printing just like this. Oh, and the third one is the cable from the opposite side of the panel, and pull it with wire into the mobile strip. So we made the panel from laser cut to try to plug into the existing. And we also made the model in grasshopper to figure out how this panel applied to our part of mobile strip. So the reflex join in detail on mobile strip by the 3D model, and to it substructure and join to the existing. This is a study case for how to join with wire.
They have the adapter under the panel, so they can connect all the panel, use the cable to connect together. And in the structure, they have the metal parts that can connect the cable.
We also use the existing screw on mobile strip here to attach the cable. And with we try to make join with 3D printer, and we made this part to attach the like here. So we
to slot in.
to slot in, yeah, to slot into the panel. We tried this panel in existing, so this is how we attach the panel to the model strip.
So we try to install in the field and find some problem. First is joint unit. The size of the unit, the light is not so it's not enough. Only 1 millimeter is not enough. So maybe we need to 1.3 millimeter is better. A centimeter is better. And the second part is the unit, the joint unit angle is not so good. So if we fix panel, the curve will become flat. So this will be realized, and need to try to think different, maybe different method or okay. And third part is we the metal part is not fixed, so if we install it, maybe cannot fix it. Okay, this 3 part problem.
Because we use the wire is not efficient to fix the panel on the street. So we need to figure out how to make it efficiently. Yeah. And the metal part we try use this to fit it not can fit on the street, so it may move and need to revise this part. Yeah. Yeah.
Thank you. Thank you.
So when you found this problem during your prototype markup, what did you have found some issues that you need to have a solution? So far, did you have any solution for all these problems that you have found?
Like this drawing, need to make bigger scale to install to the school, because this 1 centimeter and this one is 1.2 centimeter, 1.2 so it can fit.
But I thought you have measured it on site.
Huh?
You have measured the size on site.
We have measured like that. It also have out
螺纹
Oh, you measure the inner ID. You did not measure the outer ID with a thread.
But you are going to 3D print it using PLA.
But we think it's easy to destroy.
I have a suggestion, you see. Because you have your T-leaf shapes. And if you cut out this T-leaf shape, like this, I'm going to make use of this part. Okay? And you can have wings, I mean extrusions here. And then you can bend it, okay? And also here. And you can bend it. And then you use this part to make the joint. And you can punch hole here. And perhaps you bend it here. You just need to design it. And also in the middle part, you can bend it. And also here, maybe there's a way to design this. And even you can have inside. So for example, if you cut out this part, and then bend it here, and then punch a hole, and then bend going downward, and there will be a hole of it, but then it becomes a kind of decoration. Okay, so it is possible to make one piece, including joint. And I think in terms of fabrication, it might be the better solution. If you are able to make also the joint all in one piece. Okay, and I just try to use this. So it's something like that. I mean, this is ugly, but it can be something like this. So you just extrude it, okay, and of course you also have to think about like using most efficient way of using the material. So it's become a very interesting, maybe difficult, but I would say a very interesting design problem. And then you have to think of how it can bend. It can be complicated. Okay, but then.
Since you got all your accessories right here. Hold it tight. You got your component here, right? We call this component, or you call it metal part. You have to fix it. So if you flat it, just like what Professor said, it's going to be it's able to be fabricated by one piece from the mothership, right? For this, as long as you router a line, then you can bend it. Or you use one piece and you weld it, but actually it will be also less process if you use one piece, because this is ideally to be in come from one piece. And if you want to reinforce it, you can use an extra component to attach it underneath, and then you fix it. That will be easy. So I guess if you do it from one piece, then you will get a reinforcing at this area, including this knot area. You can manufacture from one piece by we call it integrate this area into the same area. And the reason why that you found that it's loosened, because it's only one contact line here. If you have a unit, just like the ID, if you have this into one set, then it will be properly help quite a lot. So I mean, make it thicker, something thicker. So then when you slot in, even you hand it down, it will be able to be tightened. Now, it's not going to be loosened like in one piece. When you have two pieces with the mechanism like that, so there will be. You can adapt the same mechanism to use it for the intermediate area. So then you can hold whatever the location that you want. And it looks to me that it's possible that you can do this from one piece already. This is one piece, right? So as long as you extend the area, since you have cut off the rest of the material, it's wastage. So as long as you grow the component area here from the redundant part, then you will become one piece, and you can change it into whatever the shape that you want it. It looks to me this is very close to be commercialized as a decorative material. It looks to me this is very close. You've done a good job for this. I believe you've tried some time to adapt all these things that what Boson is using for lot 200 to lot 300 to lot 400, and all the air table, whatever. Yeah, it's going to be the integration for a deco facade, because this is decorative facade, deco facade. Good. You have learned something from that. It is not enough time for you to design something in one semester and make it into a prototype. Actually, you need to learn the program, you need to operate the program, you need to get experience from what you learn from architecture. So you need to integrate lots of things. It's quite good, as I see. You are all very smart young men. If I were you, I won't be able to finish it in such a short time.
Okay.
Oh, one more question. When I see this film, RoboFold. When this film was published in 2012.
Yeah.
Actually, this robot arm, the movement of this robot arm is kind of very, very slow. Compared with what you can have down in the basement, it's very, very slow already. So it's a good example for you to show other classmates that you can use robot arm to do the fabrication. Actually, it will be also, on the other hand, is an opposite example, not a good example.
Yeah.
Too slow.
Too slow. It's too slow.
So when you say you have 9 classmates in your digital fabrication group, are all these are different ones? Okay.
So you are team A, right? I'm just talking to the picture. You have yeah.
And by the way, how big is the 3D printing component
Not
that you can
necessarily
do?
all.
X, Y,
I mean,
Z
you
size.
design.
How big? What is the maximum size that you can 3D print?
Shape or patterns that you want. I mean, it's not a requirement that you have to cover every single. Okay.
30 by 30, X, Y, Z. So we can also 3D print the aluminum extrusion profile, right? For the curtain wall. We can 3D
Yeah,
print
and,
the
also-
design system.
Talk to
That would
your
be
teammates.
interesting to earn some
Yeah,
extra
to
time.
estimate.
To work as a part-time,
And then you know.
as an entertainment. Because when we do the design, we don't have a physical product. So we can design it and
And
then
then maybe
3D
we
print
can,
all the part
phase through the project.
to simulate the actual.
Okay, so you don't have to spend
Ah,
money.
I would
But you have
just assume you have
to make the budget first.
to get your help to do 3D printing.
Okay, so Doris, you have to estimate how much you have to spend for the material or whatever. Okay, okay. Okay. Yeah. Okay, thank you. So it's all for today, and we have 4 weeks more, right? Till the end of semester, 4 more weeks.
Yeah.
Or 3? Only 3. 3 more weeks. Wow, only 3 weeks. Okay, so it's quite a hurry. So speed up. Okay, thank you. Ah, 我这边见。哎，这个线是谁的？Whose is this? Hard disk drive?
没有啊，就算没有你就算，他出来，有一种是找这两个地方，找出来之后，凹进去，然后下面就有重叠的部分，有重叠的部分，这叫30度。 然后就升，然后就把它就走上去了，就这样，它就会这样，它这边是最矮的一个，它就这样上去了，对啊，就这样。那其实优点就是说，因为它这样，你这边多，你这边多，这边长，对不对？你可以让这边拉长，然后这边就可以 over lapping，就是它就是两边是看，它是接在一起。那就不用那么长，那就不用也是可以。那这边这个就放着啊，就是我觉得它就可以。它有很多个。我觉得它是固定住了，因为它这旁边第一个它最下面有。这边是吧？因为这个点固定住。就是这边有。对，合进去。然后上面就这样夹。就是这样。做一个 model 给他看看。不是啊，就直接拿贴着打，然后画。我知道。就画那个，都把它改回去。因为它这样手的优点就是你可以这样转到这个形状，你可以转这个形状，也可以转这个。它是会旋转，但是它不会左右上下动。前后左右它不会动，但它可以旋转，你可以调这。手紧的话，水会固定在一条。你做那个，然后做一个修改。哦。可以。哦，这个。对。然后你可以把它加出去。好。这能不能模拟抽顶后的状况？变难。那不然我就只能拿模型去。因为它的条件是只有这一块。这个没有脱离，就是我跟他们讲的。只有3个。补线跟凹线。你现在有那个可以印吗？我印一个回去试试看。印个纸。不是，我不是用laser cut，我用那个印表机印个纸，一笔画一画那个。还是我用那个原本的原型。其实也不用，要不有原型啊。就是那个我看样子，就是他当时有10个模型，对不对？那打下来蛮赞。就像那个，那个。 我们可以比块，然后上面把直接凹进去穿。
就是这个是一整个成型的，就是连着这个，然后还是一样可以凹。
然后往内凹，然后这就这样，这个打个洞，凹进去，然后这样安装上去。
然后再用我们那个线设计好一点。
但是就会很丑啊，就是说
啊，就这样。
啊，
看吗？
是吧？就是会变成这样。
他比较好嘛，这个在那个展现业。
没有，那老师是说，老师的想法是这样的，我看老师是说，
不是画错了。
他说是这样，他说你就不要浪费材料了，因为我们旁边不是浪费材料。还有一点是，因为我们这样打那个洞有没有？它会整个它的完整性会被破坏，它的可能看打洞，然后后面，那如果他说，我觉得他是这样片有没有？支起来，然后你就稍微放个画，没有，然后就开始转了，然后就开始转，就那个转进去，然后你就可以，因为你这样压好像很难，那个还好，那两边压，然后再把它放中间一点，这样你就有空间可以转。
自己这样转。
不是，不用转圈圈哦，这样慢慢靠，比如说就那个，用反手去靠，可以先慢慢放进去。
就是它上面两边一起收起来。
对啊，它是两片折过去，然后在上面打洞。这个可以去这样看吗？
可以这个开展。
啊。
可以这个比较标准。
这个尺寸你确定吗？
对。就会是的。
那我拿这拿去用好了，我在旁边装。
拿配的，你要直接装。
直接在它旁边补墙一片这样。不是，我现在摊开来，然后自己在上面贴一片那个厚纸板。是吧？然后在那边打洞，然后再扣起来，先去对那个方向，然后去打洞，然后再出来讲这个事情。
我单点40。
不是，我先拿这个来试试看。
这样这个就拆掉。浪费。
没关系啊，反正我看他们不想要这个案子啊。
啊，没有啊，这个要修啊。
他说还是要拉。
如果可以的话，这个要2天这样。
不是老师的意思，老师的意思不是说
给建议啊，当然不一定要照常。
我觉得老师想法不错。
直接手一可以。
我直接这样手上去就好了，我就手都不用再试。
这个高度要抓，每个高度要，因为它在。
高度是取决于你要拉多。
还好像还好，因为最低的地方在。
取决于你要拉你的沟顶越深，它就越高，沟顶越深它就越高。就是那控制这个是主要是靠你下面这个，我就是这样。哦，那我想要实物去画会比较准。
再一切这样。
不用啊，你只要试着可以让我画的，画的实际的。你给我那个输出的 PDF 好了，我等下印一个这个，印一个A4，印个A4。A3。这个可以做一个。
要拿纸板。
没有啊，我就用那种好出来纸就好了。
然后纸板不准，没办法实际手。
这个，我来画。
这样这个你就拿那个上面那个板片切，就不要折中了，它只是切出来就好。 就是切外面的，他之前做的。然后他在做加这个，然后它中间会有洞，对吧？
哦，
对吧？
1.1、1.2，那可能1.2，
然后再把它进去，然后就变成蛇了。
好，我的问题。啊，它的后置盘废料应该也够，不用到，不用到整张网。
好回去。
你现在有1:29的吗？12:9的1:1模型的那个图档，我现在用一下A3的。
我想看。
对。
没有，我没带电脑。
啊？
我今天没带电脑。
哦。
只有连接档啊，连接档不在我。对啊，只有连接档。
因为我现在这边有可以印 A3的对应啊。
没有。那是你拿之前的理解。另一个 A3的出来也类似，就是跟它。
那像我还在12:9，这个12:9的1:1我觉得比较好。那直接等下之后就可以做。之后还是可以做。
比较准。
直接装。
单节点。就是它这个位置就搞在中间的意思。
对，它就会变中间。
可以。
中间是遮住那个地方。
那我继续修我的。
好。两个一起跑，看哪个状态不错。这个做得完吗？这3个礼拜。
怎么做？可以啊。
其他组都没。其他组什么都没有哎，没有什么没有啊，就是。
他们自己。他们那个也很快啊。这做很快。
上面电脑有吗？没有。
后面。
12:9了。19:2了。
我今天的话可以做晚上，晚上把它翻开。
先发那个预算。
1:5就可以了。1:5的。A3的。
不然是不是直接切就可以了？
这个这不是在一起的。
不是啊，先那个外形，然后自己再画。
问题是这样的结构就是不一样，它不是在上面。
我现在有这个外形，我就可以。
你说直接切。
不是啊，我就可以画图，画在纸上，就可以切。
是中间那条线。
对，这个是。
中间那条线你画出来。对啊。
不说。看你礼拜几比较有空啊？礼拜2号。那个还好。
晚上再传给你。然后继续弄我的。
那我然后我上去拿个废纸，就是有些那个纸没用的，可以切，切19/2就好。